All right, we're live again, everyone. And if you were following along at all last night, I know it was a little late for a lot of you in Europe and such. I try to be available for streaming when I do this in a time that makes sense for a lot of people, but obviously I can't make sense for everyone everywhere all at once because there's at least 24 different time zones on this planet. Um, I thought supporting the test from Python to C++ will be fine. Uh, these are the exact same techniques I use for testing in C++. Anyhow, so if you were here before, you saw that we have corrected all of the field of view, and no, I don't want to. Sorry, I'm trying to actually play this current file. We've corrected all of the field of view and fisheye issues, but we do have an actual problem that needs to get fixed here. So I'm gonna just get this running again. We haven't actually run the game since we split the test out. All right, so if I am at a 90-degree angle to a wall, let's get this over here, then I've got this weird line intersection problem. Oh, of course it's not showing up now. Fine. We'll go over here to the other side where I know I've seen it before. There we go. See that flash that just went past? There. So this line right in the middle of the screen, it shouldn't be there. And I am in the process of adding tests to this. And my goal for today's stream is to identify where that error is happening through a test and fix it. And it would be a bit strong to say we're doing test-driven development here because we clearly didn't start with tests now, did we? So that's would make it a bit of a lie. To say it's test-driven development is just kind of post-tested something. I don't know. All right, so we've got our geometry test file here, and what I was doing is writing test to make sure that the slope was what I wanted it to be when coming from a line segment into a line. That's what I had been last testing. So I'm going to add more tests that involve converting between rays, line segments, and lines. And we'll see what falls out. Okay, so we have these line segment properties. Let's see what other properties I might be missing. Okay, so I don't have any conversion to ray scenario here. So let's go ahead and add some tests for that as well. Now, I think this is how I want to do this. That ray is actually a function, not a property. Let's look at that real quick. Yeah, so that's a function. It's not a cached property that I have set up right now. So the question is for if I can suggest any videos for what I'm currently working on. No, I've gone outside of what people normally say is raycasting because I allow very arbitrary geometry. So the main thing that I can suggest is that you watch like the previous 6 hours of streaming, which is probably a bit much to ask, but I am planning to edit all this down into a succinct series of videos. The debugger in the thumbnail of the live stream. I don't know. What does the thumbnail look like? Um, Shoot. Oh, oh yeah, that is my own personal ARM emulator that I wrote, and it's the thumbnail from that. I believe that's what you're talking about. Okay. So if I've got a zero slope, I expect that this is going to create a ray that starts at the point 0, 0 and has a direction of, so this is going to be 90 degrees, which is pi halves. That should be correct. Why is that not? Unresolved reference math. What? And this one is a slope of 1 to 1. So that's a 45-degree angle. That should be pi over 4. And the -1 slope should be pi halves plus a fourth. That's 3 pi halves. Yeah, that should be right. And then the one that's vertical needs to have a ray that starts at the origin still, because that's where I have all of these tests running from. And its angle is going to be 0. Yeah, I think that's right. So let's see if these tests pass. Test failed. Test fail. Why? What failed? Oh, I didn't actually make that a function call. Yeah, bound method of ray. That's not what I wanted to do. I wanted to actually call it. Click to see difference. Test 13. Yes, okay. What's the actual I need on that one? -1 slope. I clearly got that wrong. Okay, so pi half is 90 degree. This needs to be 135 degree slope, right? Yeah, I mean, that's the direction that it's going to be going in. If it's x is 1 and y is -1, then that is pi halves plus another quarter, right? So that's 2/4, and so it should be three quarters, right? Yeah, that's 3/4. What did I have a moment ago? Did I have 3/2? Okay. And I'm doing floating point comparison, but yay, it seems to be working dangerously, perhaps. All right, line too long. Yeah. Now, I asked yesterday if anyone knew a good way of running the black formatter from inside of PyCharm, and no one gave me an answer. So I'm just going to run it manually here on a few of the things. Let's make sure everything is nice and uniform. That's weird. My chat just cleared out. Well, you all still seem to be there. All right, there we go. So, okay, that works. I think, have we tested all of the major properties of line segments? Let's look at those real quick. Min, max, slope, line, on segment, and ray, and end and start. All right, I'm not worried about those, but we do need to do some on segment testing. And I was thinking about that a little bit last night. So the idea is if I've got a line segment, I should be able to plug any point into it along that line segment and find out if the value is, you know, on the line segment, basically. So let's add another test. This is going to be test on segment. Ooh, a corner case with points. Oh no. Yeah, okay. All right, so if I did that, the slope, fine. All right. Well, what is the expected case? Since you just asked about that. Yes, the fisheye was solved. I did that in the stream last night. Sorry to not have a good answer here. Yeah, nans are fun to debug. Shoot. All right. All right. So let's just say I'm creating something that is from 0 to 0. Well, let me add a body here to this. What do you put if you put a what is the Python keyword for a no-op? Pass. That's right, pass. That's what I want. Let's just make that so that will run. All right, so if I'm going from 0 to 0, the min and the max of all the things is clearly 0. And a line is going to start there. And now what's its slope going to be? Its slope is, should it be nan? Should it be none? Should it be 0? It's not a line. Arguably, asking to create a line from it should throw an exception or something, right? Because it's clearly not a line. Slope isn't defined for it. There's no way to generate a formula for it. And array should also be undefined. Those are the things that should throw errors, I would think. So let's just see what it would do currently. Yeah, should it return none? So it actually got back something with an actual angle, huh? Expected. Do I have these assertions backward from what PyTest expects? Oh, I'm redefining this first of all. Let's see. Just call it a point segment. I don't know what it's creating back for me. That's disturbing. Okay. Oh, right. So it's returning back whatever's going to be gotten from this atan2, which has then been corrected to take it from the direction, the angle above the x-axis to the angle away from the y-axis. So that's the correction that I'm doing here. Yeah, so atan2 is probably returning 0, and then I'm adding pi halves to it, which is why I'm getting this angle of 1.57 here, which is, yeah, offset by 90 degrees. It's... I think it should return none. I really do. Let's do that for now. I'm going to return none. Or should I throw? I really don't know the best way to do error handling like this in Python. Yeah, 0 divided by 0 is clearly a nan, but I don't want to give it an angle of nan, do I? I could return a ray or a line with an angle of nan. I don't love that. Or I could return none from both of them, which then forces it to be caught as an error later, but then you have to actually theoretically check the ray or the line segment or whatever to see if it's going to return nan. I mean, should you even be allowed to construct a line segment with 2 points that are equal to each other? Because is that a valid line segment? I think I could argue that that is a valid line segment, but clearly you cannot create a valid, correct ray or line from it. So, Svetan, if I can attempt your name there, says, I think it clearly should throw an exception. Clearly should throw an exception. All right. Throwing on creation of the line segment, or throwing on creation of the ray itself, or no, I can't throw on creation of the ray. I need to throw in the ray function here. All right, let's try it. Let's try it. I've never done exceptions in Python. Let's do a quick Google, even though the rest of you know this, I'm sure. Break, no, try, fine, except. No, oh, I see, that's catching exceptions. Pass, fine, raise. Oh, it's called raise. All right, so what kind of built-in exceptions are there? Built-in exceptions and their meanings. Okay, base exception, no. All built-in non-system exiting exceptions are dry. Okay, fine. Arithmetic error. Arithmetic error is an arithmetic error. It's an overflow. Zero division. It's kind of a zero division error. We could call it an arithmetic error. Oh no, wait. So does that mean I can't create? Oh, that's a base class. An arithmetic error is a base class. I could end a file. Attribute error. No, floating point error. Not currently used. Spectacular. Import error. Runtime warning. Memory error. Name error. OS error. Recursion. Runtime error. Raised from errors detected that doesn't fall into any of the other categories. The associated value is a string indicating what precisely went wrong. Could certainly start with that, and then we could make it a little bit more specific in the future if we decide to. Runtime error or runtime warning? I don't even... Base class for warnings about dubious runtime behavior. What? Yeah, I'm just going to throw an exception here and warn you that you might be doing something dubious. That, I don't know. That strikes me as hilarious somehow. Dubious. I'm gonna go with runtime error right now. And so this has got a cannot create a ray from identical segment points. Okay, and I'm gonna need basically the exact same situation. For line. Had too much coffee this morning. I'm like pacing here. It's really weird though. I just learned, confirmed, if you will, that drinking coffee actually does decrease my heart rate. That's weird. given that it also makes me feel anxious, it doesn't make me feel sleepy. Okay. Let's make that its own test. By the way, again, if anyone from JetBrains is watching this video, I would accept your sponsorship of the channel again. Yeah, no, I don't drink a lot of coffee. I quote, use coffee. I only drink it when I know that I'm want a little bit of pick me up, basically. But I don't know, it clearly doesn't work like it's supposed to on me. Sure, let's call it a point segment test. And I don't want to run these normal expected value test on it, but we need to look up the rules in PyTest to see assert exception. I know that was one of the examples that we saw. Ah, here we go. Use the raises helper to assert that some code raises an exception. Okay. With pytest.raises. With pytest dot. Ooh. Look at all of the things that it has here. Raises. What did we just call it? This is a runtime error. Am I doing that right? I haven't, yeah, okay. I'm going to change some of this in a second here. So this is it's two different questions here. Probably asked before, why am I doing Python? Because I wanted to practice Python. It's quite simple. And then the other question of, can you default init a line with length 0? These are line segments specifically. We do have to be clear about that. You know, like a line in geometry is a thing that has passes through some point in space and has a slope and is infinite. A line segment is something that goes between 2 points. It's bounded. So these line segments can be created with 2 points that are the same. That's definitely a thing. Whether or not it's an intelligent thing is an entirely different question. But I think creating a line segment that is dubious, if you will, maybe this is where I should throw a dubious warning, it makes sense, I think. All right, so line can be replaced with a function called have effect. Okay, so line, ray, segment, line. Wait, that is set as a cached property for segment. I need some consistency here. The question is whether or not these things should be all cached properties or functions, or if it should be called, called toRay. Ray is clearly, line is clearly a property. Oh, wow. Whoa, lots of conversation here. This is all Python. Yeah, if I had a line with it would be a bounded line, which is a line segment. I'm going to keep it how it is at the moment, I believe. to return an option or raise an exception in this case. Yeah, the BNet gallery seemed to think that raising an exception was the thing that made the most sense. Yes, for a line segment, definitely need 2 points. Okay. All right, so right now I'm going to... okay, I'm going to take a step back here. This line cached property for segments is just used like all the freaking time because I need it for doing intersections between segments, because doing intersections between segments is kind of a pain, but doing intersections between lines is pretty easy, and then you can bounds check it to see if that intersection actually occurred on the line of part of the segment that you care about. Okay, so I use that all the time, but the ray thing is only used in the cases where I need to take the segments that are being cast from the camera to the planar projection into a ray for then doing the intersection to see if a point is currently visible on the column that I am casting. Okay. I'm catching up on your comments. Yeah. But I think, again, I think this makes sense for how things are represented in my geometry, because creating walls, those are all segments, and it's easy to work with that way. But I'm still trying to decide if this cached property, if ray should be a cached property or not. I don't think so. So for consistency, I'm going to change the name of this from ray to 2ray. Do refactor. Theoretically, you did that right? JetBrains, you did that right? All right, so that should be a function call because it's a function call. And this is bothering me because this is a cached property. I want to know what happens if I execute this. It did correctly do that. I think this is just kind of a, what happens if I explicitly treat it as a function instead of a property? That also says it passed. I need to test a few other things here. Can I do an assignment? Just for the record, all of these geometry, well, not all of them, but most of the geometry types are data classes. So they are, oh, wait a minute. Oh, no, wait. So point and line are named tuples. Segment, it's not a named tuple yet. I need to fix that, because I want basically all of these things to be immutable. Why did I not have that as a named, all right, I need to get to that in a second. You think it's passing because it throws a runtime exception. Well, that's spectacular. That doesn't help me at all. Yeah, I'm gonna do that right now. I'm gonna test a couple of things. Now I'm just gonna create a valid one here, and then All right. I want a test for something that doesn't raise, basically. That a certain exception is raised. I want the opposite. All right, that doesn't seem to be a thing. Oh, sorry, Colby. Can't help. YouTube. Bah, humbug. Does its own thing. Is there like a maybe unused or something like that? So that I can. Yeah, let's do it this way. I don't like the grayed out thing here. No. Yeah, yeah. So for a lot of people asked yesterday, why in the world don't I just have a vertical line have a slope of infinity? And it's because then like everything becomes infinity in nans because stupid IEEE floating point rules, I mean, that's what they're supposed to do. So I kind of have to be a little bit more explicit about that. Let's run these tests and make sure these things are doing what we want it to do. Okay. This appears to be working. I wish that I could get more output, like... You know, it tells me how many assertions I had, basically. That would be cool. I'm gonna just double check this, though. Make sure this is all doing what I want it to do. Failed. Because that cached property cannot create line from identical segment points. Okay, they're good. All right, and just a sanity check there. Again, like I want like something to say that the result is intentionally not used. Oh, a double underscore. No, and you know, oh, right. Oh, no, wait, that was rejected. What? But that is a thing, right? In Python, if you want to say a value is unused, to do that, right? Yeah, right. Alternator. That's what I was just remembering. Okay, so I want to create a range of values. So I'm going to use a list comprehension, I guess. Or you could just skip the assignment, but then I'm getting other warnings from my IDE saying, hey, I'm calling a property, but not using its return value. So, you know, it's one of these catch-22 things, True Blood. Just trying to satisfy all of the tools. All right, so if I want to test that a segment is on a segment, now I'm going to create something that's kind of, let's see, it's going to go from like negative 23x to a y of like 10, and then it's going to cut down at like 15 to negative 32, something like that. So we're making a line segment that's just kind of cutting across our coordinate space. And now what I want to do is, like I said, I'm going to create a list comprehension of a bunch of points that I expect to be on this line segment. So something like, yeah, no, don't use void in C++. That's old school, old school. I'm going to do a quick C++ lesson here. How's compiler explore? Oh, right, this is a new setup here. Hey, C++, for anyone who wanted to talk about C++, here we are. Let's zoom this UI in. So if I've got some value, and now I'm going to get an unused warning if I've got any compiler options turned on. Should tell me that 42 is unused as of C++ 17, right? We would mark this as maybe unused. Oh, seriously. Auto. Right? That's C++ 17. Is it 14? I'm going to double check. Oh, it's 14. 11? It's 11. Is it 98? No, it's not 98. That's going to fail to compile. Okay, yeah. Sorry. C++ 11. There we go. Yeah, maybe unused is a handy attribute syntax. And it's going to come into... If I do this, and I call get value, now we're going to start... sorry, let's put that in 14 mode so this compiles. Okay, now this doesn't raise any kind of error with most tools, but if I were to mark this as no discard in C++, then I'm going to get this warning return value ignored. So then I'm like, fine, auto value equals this. And then I get an unused variable value, which is right back where we were before. So it makes it intentionally very difficult to ignore the return value from a function that is marked no discard, and you kind of have to make your code noisy in this case, which is 100% the point. If you're indicating to the user of your code that ignoring the return value from this function should be a warning, then you need to make it noisy to indicate to the user, the reader of the code, that you're intentionally removing that. Yeah, I thought it was C++ 17 as well, but I'm not getting, oh, hold on. Sorry. And tick. Eh? No. Yeah, GCC has no problem with this. Yeah, I agree. No discard should be the default thing. I really also thought it was C++ 17, and I'm confused. Let's put it on like Clang 15 or something. Yep, C++ 17. Clang has the correct warnings here. GCC does not. All right, that's all C++ 17. That's how I recognize guys at work who watch you. They use no discard. Score. Okay. You know what? I would be very happy to come to your company and do on-site training wherever you happen to live. uh, so, yes, I do C++ training all over the world. I love doing training. I just got back from uh, Sweden, actually. I'll be going to Canada soon. Great times. Okay, so I'm trying to generate a list comprehension. I don't even know. No, no, no. Use may be unused. May be unused. Don't cast a void. Stop doing that. May be unused. That was the point of my whole little segue just now. All right. I'm still getting used to the list comprehension syntax. All right. So, Blue Robot here. I've been there. I've done training, by the way, at companies where someone like you specifically says, hey, we really need to get everyone on the team up to the same, having the same conversation about what our C++ should look like. And the idea is that you bring in me, an outside expert, because, you know, quite frankly, they're not going to listen to you. And that's not your fault. It's just the nature of humans. You can tell them something and then you bring in, quote, an outside expert. They can tell them the exact same thing. And then they'll now listen to the outside expert. So talk to your senior developers or team leads or whoever and say, hey, can we bring in an outside expert so that we all have a conversation together and get everyone on the same page for what our C++ should look like, and then contact me. Is STD? Yeah, it can be hard to. Hold on, I need to see something. I had literally no idea that std ignore was a thing. That is really weird that I had no idea that that was a thing. I will have to do an episode on that later. That's weird. All right. Oh, my mind is currently blown. Okay. I do not have Udemy courses, actually. Uh, Sorry to disappoint. Is that just warning that I've gone off the end? Yes, fine. All right. All right, so I've just created a set of points that I expect to be on this line segment. So how do I want to do that? That is an assert. PyTest. No. I want the, where did my reference go? Reference guide? Uh, yeah, yeah, I agree. It's a non-standard attribute, but GCC should have given me warnings since I was clearly using it outside of the language standard that I was using. So GCC is just wrong in that case. Oh wow. What am I looking for? Warns. Oh, all right. I just need a cert here. All right. So I want to assert that all of the expected points are in fact on that line segment. Okay. Now I need to create what, like a set of random points that are not in the expected points and make sure that none of those are on the line segment? How should I do that? Should I, no, random is weird. How do I create a bunch of points that are definitely not supposed to be on the line segment? If I just add a value to x, like 0.1 or something like that, or 0.001, and then I know that I'm creating a parallel set of points, and none of them should be on the line segment. I guess I could do something like that. Not sure how useful this test is, but it certainly doesn't hurt. I definitely had bugs with determining if things were on the line segment before. Filtering problems with CLI on new Mac OS. I don't use Macs. I sold my Mac so that I didn't have to answer questions like that anymore. Ooh, intriguing. A test failed. Why? Assertion error. Assert not true. Aha. Interesting. So it thinks that 22.99 with a y of 10, so basically the start point, is on the line segment. I might have found the vertical line bug. We're still only on line segments. I've got rays and regular lines to go through as well. All right, on segment. Oh, all right. That's a very loose interpretation of on segment. I wrote this code expecting to actually this code doesn't do what it says it does on the tin. On segment actually says within bounds. That's what it actually does, I think. Because it's just checking if the x was within the range of min x to max x and the y is within the range of min y to max y. And I did that as a faster bounds check than actually checking to see if the point is on the segment. That was intentional. So this function should be renamed, I guess. Oh, I'm new to Python too. Don't ask me when you should use PyCharm versus Jupyter Notebook. On segment versus within bounds. How do you actually check to see if a point is on the line segment? I mean, I could convert the thing to a line first, see if it's on the line, then see if it's in bounds. See, I already know it's on the line in my raycasting code. Yeah, I'm agreeing. I have to check on the line equation. Yeah, all right. Like I've gone outside what I intended to do here. Huh. Check the distance from the point to the start point. And then verify its slope to make sure the point is on the line. Oh. That's an interesting point. So if I create a new line, actually I'm gonna, that's interesting enough to explore. Yeah, if I create a new line segment that has the current origin plus my point in it for the end point, and the slope is the same, and it's in bounds, then I know that it has to be on this line. Except in the case where my point is equal to the start. Oh, huh, I don't know. That's a thing to try. Failed. And expected points on segment. I'm going to debug this. Yeah, all right, that's clearly going to return true. Okay. Now, in the case where okay, it's a floating point rounding error, basically. So all right, cool. All right, well, all right, so that I think tests a fair bit of things. Segment on segment. I've got lines, arrays. Let's go back to the structure here. I kind of wanted to show me the structure of the whole thing. I don't want to have to go back and forth, but all right, fine. All right, inbounds, to array, on segment. All right, I think that's good enough for now. We need to start doing things like ray to line. Oh, that's not using my shoot, what's it called? Vertical slope constant, which it should. Oh, and I just realized I want to, wait, what is this now? Oh, too many blank lines. It's very important that you have the proper number of blank lines between your things. Hello. There we go. I want to make a couple of changes real quick. Sure. I want to convert this to a named tuple, I think, because I think that makes sense. It's immutable. I don't want the segment to be able to change. It does have cached properties. I think that that makes sense to create this as a named tuple instead of using data class. I believe that is also true for Ray. Let's see if that actually still works. Nope. Cannot use cached property instance without calling set name. Oh, that's why. because I'm using cached properties. That's why I didn't have them as named tuples. All right. Oop, whoa. So I don't love that. Yes, metal. I am using black actually, and I'm getting these warnings while typing. I just want an easier way of rerunning the code formatting. I'm going to. I'm going to go back to trying to make this a named tuple. I want to understand this issue. Because I don't like this unsafe hash that I'm currently doing. Segment is not derived from line. No. All right, so I want to know about a cached property on a named tuple. Currently, there's no way to use cache properties as named tuples or other immutable classes implemented the same way. Right. Because named tuple no longer has the dict attribute. Okay. I understand why it's failing. Are there use cases? Yes. As a workaround, use data class as a named tuple. Yeah. So here's the deal, and I have directly observed this. If I actually make it a frozen data class, it slows the code down like shockingly. And that bothers me, which is why I've ended up doing this unsafe hash instead of a frozen class. Could use LRU cache. It's not the same behavior though. I like cache property. Bother. All right. Let's just put this back how it was. That code was working, and I was getting ready to start on testing Ray, I think. So distant point literally just creates a point that is far away, quote unquote, far away from where the ray's origin is. So it creates a segment that starts where I would start and goes in the correct direction for, 100 units away. And the idea is, the rays that I need to create for intersection tests, or the segments that I need to create for intersection test. Yeah, yeah, it is hard coded right now, right? That doesn't sound good, does it? Um, I don't know what to do with that. I don't use infinity, that doesn't work. All right, I'm going to take a quick break. If you all have a good idea for a better way to handle the distant point idea, let me know. I don't know how much longer I'm going to stream, just for the record. Thanks for hanging out. I'll be back in a minute.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
It's 4 minutes till showtime.
Hey, fellas, don't fight over that hot dog. There's plenty for everyone. Big, plump, and juicy, wrapped in an oven-fresh bun. Add mustard, relish, ketchup, and go to work. Yes, the hot dogs at our refreshment center are the best you'll find anywhere. Everybody agrees on that.
It's 2 minutes till showtime.
Your attention, please. All new hotshot electric in-car heaters have been installed for your comfort and convenience. Just insert heater through car window and turn on the switch. When leaving, please turn...
Yeah, I agree I should name it at the very least. There's lots to deal with here. Line is very, very simple. It has no properties on it at all. Let's start testing, Ray. I want it to still show me the structure from geometry. I don't know how to use that feature. All right. Yeah, all right. Okay. Yeah, all right, all right, all right. I'm gonna end up doing something similar to what I was doing with segment, so I'm just gonna steal this real quick. I know I copy and pasted code, but I just want to get the format similar. So I'm again starting at origin for right now. And I'm going to pass this to expected. Zero angle. Yeah, promoting TDD as in I should have done this from the beginning. Um, um, yeah, no, I don't actually need to test those things. Start X, start Y. No, that doesn't make any sense. Slope, what do I need to actually test on the ray? I need to test its two line, its two segment, and its distant point code. Yes, okay. Let's start with looking at two line. Okay. Yeah. I think I have a pretty good idea for what I'm going to do here. So if this is a line, it should be now. So this is something that starts at 0, 0, has an angle of 0 relative to the y-axis. So that should be pointing directly up. So if it's a line, then the line should be equal to a line that has a geometry dot passes through 0, 0 and has a slope of vertical right, should have a vertical slope, and its segment should be something that goes through or starts at 0, 0 and goes through, quote, distant point. Yes. Right. So the distant point, we have to now actually define it. I guess I'm just going to call that distant point. I don't like the name though, but fortunately, since we're using a nice IDE, we can do renaming of things with no difficulty. Which means it wants to go through geometry of point of x is still 0 and y is going to be distant point. Right? Right. Pretty sure that's right. And again, I have the wrong number of blank lines. Well, that seems to have done the expected thing. So that's array that starts at origin, and I want it to go pi fourths. And then I'm going to have a 45 angle. It starts at 0, 0 as expected. And now it is not the vertical slope number. It is going to be okay. So the slope of this is going to be 1, right? Ha. Just came home from work. How's the test writing going? Well, we haven't actually found any bugs yet, but we did find a few places where we want to throw exceptions when we can't properly create something. So I don't know how long ago you were last here, Christos, but we're doing something today. Definitely doing something. How long have I been streaming? An hour and a half. You should share with your friends to come join this excitement. This is truly exciting, isn't it? All right, so if I've got a 45-degree angle, then my distant point is going to be not the distance point of x and y. It needs to be that distance from my current origin, which is, what is that? That's the square root of 2 times distant point? No, that's not right. A squared, so if I'm the square root of, yeah, the square root of 2, right? No. That's, oh goodness gracious. This should not be complicated. Just a second. Half square root of 2, is that right? All right. So I'm basically saying if I'm here and I'm going in a 45-degree angle, wow, that is incredibly slow while streaming. And I just want to know what is the x and y part of that. And so Pythagorean theorem is the entire length of the thing is distant point, right? And therefore the x component is the square root of yeah, I am just trying to compute the sine of pi fourths. Whatever. That's a fair enough point that I'm just going to type it. Could have used Pythagorean theorem. Those should be the same value, right? I feel like I'm losing my mind. I've been doing this for too long today. Failed. No. All right. Yeah, I knew it was bound to happen. All right, so how do I want to actually test this? Don't want to override the equals comparison on the segment. I don't think that would be a fair thing to do. Um, yeah, floating point comparison is always dubious. Is there a floating point comparison built into? We have to check this now. PyTest dot approximately. Wait, I don't understand how that's supposed to be used. Start with two numbers or two ordered sequences of numbers are equal to each other within some tolerance. Uh-huh. Uh-huh. Yeah, I get it. Tolerances, blah, blah, blah. Okay. Oh, I see. All right. Fast. All right. Okay. That's doing what we wanted it to do. So we've tested distant point going up 45. Let's check a right and let's check directly down. So the slope in this case is going to be oh. I think I might have just found a bug. Well, you would prefer it, but I'm using why not? I mean, I get preferring is close, but it seems like approximately does exactly the same thing, but it's within the testing framework, right? Is that a problem? You all vote on that one. Wait, what? Expected a slope of 0. Got a slope of very small number instead. Okay, well, those are approximately the same, are they not? Oh, I see. That is on the segment creation. Oh, okay. Hmm. This isn't the bug that I expected to see. $137. Right angle. I say create a segment from it. That's weird. I mean, it's floating point math. That's very close to 0. Hmm. Hmm. Oh, I kind of like the PyTest approximately one. No, that's right. Okay. Here we go. Wait, what? Now I'm failing on the first one? Oh, that would be why. Yeah, thank you. That's the problem with copy and pasting code. I need to write like an approximate point test is what I need to write. 148. All right, this is where things went wrong and I expected them might go wrong. I do need an approximate point test, actually. Maybe I should write an approximate equal. All right. Test array properties. Expected. Very small number. Got actually a very large negative number. Okay. I know, very large. Okay, I see. All right. Now, the question that I had is in this 2-segment code. No, in 2-line. Let's look at something. So I say if the sign is equal to 0, then give a vertical slope. Okay. All right, so a slope that's very, very steep up versus a slope that's very, very steep down are almost indistinguishable from each other. That's clearly a very small number. Almost 0. It's approximately 0. But the sign of 0 is definitely 0. So the question is, how do I deal with this? Do I say if it is a ray or a segment pointing down, then I want to actually give this very large negative slope. I think that's what I want to do. Excuse me, very small negative slope. I think that's what I want to do. So huh. The only case where I have to deal with it is straight up and straight down. No, those aren't the only two cases I have to deal with it. Because I do have I need to normalize this angle because the angle could be like 75 pi or something like that. And we're going to get the exact same scenario. Well, not 75 pi, but you know what I mean. So, how do I want to do this? Maybe I just want to say if the sine is approximately 0, then give it the vertical slope. Fine. It's a vertical line with a very, very steep slope. And from a math perspective, that is indistinguishable from one with a very, very steep downslope. Now, you know, none of you are commenting on this. So I think it's the route that I'm going to go. So if the sine of the angle is close to 0, then return vertical slope. And then in my test here, so this might actually solve other problems. This might solve the other problem that we've been looking at. And then if I've got the 180, then I'm just going to say that this thing is the vertical slope. Just not reuse distant point. Well, I really do want this thing to have the negative vertical slope if it's pointed down, because that would give me consistency later. Using imaginary numbers instead of an angle. How's an imaginary number going to help me here? I would need more input on that one. Calculate the end, then calculate the slope from that. Oh. Reuse distant point to calculate the slope. That's an intriguing point. Yeah, I thought about the, okay. Use the modulo operator. Yeah. Yeah. It would be nice if I had some sort of ability to, after construction, normalize the ray. But I feel like I should normalize it instead on creating these new functions, which is what you're getting at here. So 2 pi, yeah. All right. Wait, can you actually do that in Python? Floating point modulus? Wrong. So that's 4.2, which leaves 0.4. Okay, yeah, you can. Apparently, you don't need fmod in Python, apparently. You know, I don't really know if this ultimately makes sense, but I kind of want to think that it does. Um, it avoids doing any trig until I have to, I guess. You should use, I am using PyCharm. This is PyCharm. Help. About PyCharm. Ooh. See? I don't like the idea of overriding the angle every time it is accessed. That to me doesn't make a lot of sense. I want to treat the type as immutable. Okay. Where am I failing now? Line 134. Now I'm back up at the 45. What is happening? Good thing we have test. Test array properties. Line 148. All right, we're now back down into the failing thing, finally. Well, into the code that I expected to fail. So expected negative wait, what? Yeah, I got it in the parentheses, sorry. Uh, oh, it's the distant point. It's the distant point. Right. That makes sense. Okay, good. Good. That makes sense now. All right, I feel like we actually fixed something here, so maybe I'm asking too much, but I'm going to try actually running this thing. And I don't know how to, like, I need a target for this. I need a main, I guess. It's fine. All right. No. So we haven't fixed that intersection issue yet. I did see that flicker past. But yeah, it's still flickering past every now and then. But it still looks correct and our tests are passing. Yeah, it's all CPU. I'm still getting a flicker of that vertical line from now time to time. So we clearly, well, definitely have more tests to add, right? So I've got these rays at weird angles that are expecting what I expect them to do. I need to reformat this file. All right. All right, so I've got those tests for creating lines and line segments from rays. Let's verify. Distant point, line segment. I feel like we have tested that stuff pretty well. What I want to do now is something like line, let's see, segment to line, no, ray to line to ray, that kind of conversion. And I'm probably going to regret it, but we'll see what we've got. Well, actually, wait, am I done here? No, I still need to test line. Oh, no, wait. That's segment. Line doesn't have any properties to test on it at all. Okay. And point also, I've tested adding of points, right? That was the very first test that I did. Yeah, I did. Okay. Oh, you know what? I should make sure that I didn't break any other test. Ooh, neat. They all pass. Okay. Okay. Geometry, segment, ray. Okay, so yeah, I want to test things like ray to segment to ray. Yes. And ray to line. Yes. And ray to segment to ray. Is that the only round trip one that I need to worry about? If I did ray to line, I don't have any way to create a ray from a line because I don't know what the origin should be. There's no logical way to do that. So ray to segment to ray. Yeah, that's the only round trip that I think I can do reasonably. Well, this is going to be a thing to test, isn't it? All right. I need like some sort of, I don't know, some better way of creating these specific test cases. Oh, this one, round tripping, I could easily create an entire ray to line and segment to line. Ray to line and segment to line. Should produce the same output. Ray to line and segment to line. Yeah. 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 Yeah, I should be able to test those also. Agreed. I'm tired of doing these written out words. So ray segment round trip. uh, probability that this is going to work on the first try is extraordinarily low, right? I'm pretty sure this is low. Oh, come on. Oh. I mean, it's very good, right? I mean, it's floating point math. I can't really ask for better than that, but I want to ask for better than that. Like, I know, it's not going to work. We know it's not going to work. Fine. Fine. It's very annoying. All right, well, it worked better than I expected it to. Let's go ahead and add in a bunch more tests here because it's relatively easy to do. 270 is is 3/4. No, that's pi plus a half. That's pi plus half a pi. That's 4/3 pi. You all like watched me do this exact. That's not 4/3. What am I doing? It's pi plus 1/2 pi, which is 2/4, 4/4, 6/4, 3. Three halves. It's 3/2. Oh my goodness. I feel like I shouldn't be allowed to do this math in my head. Some sort of rule against it. I just realized where we're going to get ourselves in trouble again. You can just use tangent for calculating the slope in 2-line. That was in segment 2-line or ray 2-line? Ray 2-line? I could use tangent. Oh. Right here you're saying? But I do still have to check for 0 because otherwise it's... Otherwise I'm still gonna... Yeah, 0 would be 0 slope. Yeah, I can't avoid that problem. I can't create a line with 0 slope. Well, I mean, I can create it with a 0 slope, not with an infinite slope. That would, yeah, infinite. That's where the problem would be, right? Because tangent goes to infinite. Yeah, so I'm going to keep it like this so that the rest of the math works here. It won't be infinite. Let's test that. I think you mean 3 pi divided by 4. Yeah, so the question is math.tan ever going to return infinite? It doesn't seem to in this particular case, which does make your argument valid. But Is that defined? I'm going to look at okay. Yeah. I mean, it was a good idea, but I don't think it's something I can count on. I feel like I have to. Range error closed due to underflow after round. Okay. This argument is infinite. That doesn't help. Yeah, we know that. I'm nervous about a change like that right now. I kind of want to stick with where I had been going without any kind of guarantee from any of the implementations as to what they would actually return. I think what I'm doing is all right. So I just realized that our angle normalization is going to get me in trouble here. So if I wanted to create something with an angle of 405, for example, then that is 2 times math dot pi plus pi quarters. This isn't going to round trip. Because I'm not normalizing on construction of the ray. And like I said, I do want to kind of, if you will, respect the ray. But there's no way to take that to a segment and then back again. So I think I'm just going to have to test to see if they are equivalent. Yeah, it failed exactly as predicted. So I want to test if the angle modulus math times 2 pi is approximately equal to the new angle. Wait, what? Angle 270 should be 3 pi quarters? No, it's definitely not 3/4 of pi. I made that mistake already. It's 75% of 2 pi, not 75% of pi. 75% of pi would get me a 135-degree angle. Yeah, okay. See, we're all practicing our geometry and trigonometry skills today. Are we having fun? That passed. I'm going to make a quick change without testing it. Rotate right here. So I happened to be on the exact line. I have an angle, view angle on my camera and this is where I risk the possibility of rotating past 360 degrees. So I'm going to do the exact same normalization that we had been doing a moment ago. That'll make me feel better. Hopefully that works correctly. It'll be a good test in a moment, actually. Let's just go ahead and run this current file. Yeah, that works right. Notice how if I don't have anything on the screen, I get like 160 frames per second. It's awesome. So should I use fmod instead of the built-in modulus operator? No, but that's not going to give me the negative behavior that I want. Whoa, what is happening? I feel like I slowed things down a lot recently. I have to dig into this at some point again. It's definitely going slower than it was. Oh, but I also have this really wonky wide angle thing. I'm going to change that to a more germane. Like 800 by 480, something like that. Wait, so I haven't found our bug yet. Ooh wee, look at it go. Zoom. That's pretty good. So yeah, I still haven't found that bug, have I? Interesting. I'm gonna go back outside and see if I can find it. Oh yeah, wait, hold on. Yeah, there we go. That line straight down the middle. Whoa, wow! I can pass right through the walls because the intersection doesn't work correctly. And I just got embedded in a wall. Oh, why is the intersection test not working? All right, so we have to actually do intersection tests now. The round tripping looks good. Intersection tests need to be next. Intersection test on a perfectly vertical line segment with a perfectly vertical, horizontal line segment. I don't even remember how my intersection classes are written right now. All right, intersect ray. So I have a ray and a set of segments, and it returns to me the segments that intersect with said ray. Fine. If I, so that calls intersecting segments. Okay, right. So that takes array and it converts it to a segment, which is how far out. So I can actually limit the depth of this thing by changing what counts as distant, and it just won't even try to intersect things that are too far out. Intersecting segments takes an input segment and a set of segments and returns back to me the set of segments that intersect. And I probably could do this with a list comprehension or something, but I have a couple of tests that I need to do, like do the slopes equal each other? And if they do, they don't even try to do the interception, for example. And then, yeah, so I do a bounding box test, first of all. Actually, input line dot slope segment line. Yeah. So I do a bounding box test to see, like, are these segments even in the same ballpark? And if they're not, then I don't bother doing anything else. I continue. Okay. And then I say, get me a line from the segment. And then I say, do these two lines intersect? And if the lines do intercept, then I make sure that they intercept at some point that's within the bounds of the two line segments that I am checking for. This is all way more probably could be done much more simply. Yeah, I see your comment there, Sveton. Should that be is min x less than or equal to max x? So I'm checking to see if two bounding boxes. I'm actually kind of curious. That would be bizarre if that was actually my problem. No, I still have that. Oh, I really do need to fix that. Oh, that's awesome. I'm actually inside of a triangle. Maybe this is a feature, not a bug. Oh, and I can't escape. All right, so a quick, let's see, we want to do geometry intersection test. I'm going to start with the thing that I know is causing a problem. So that is my horizontal. Passing straight through origin. I should probably go soon, by the way. I have to do actual life things at some point today. What have I been streaming for 2.5 hours already? Oh my goodness, yeah, I really should go at some point here. All right, I'm going to write this test and see what we find, and then I'm going to head out. Intersecting segments. And I'm going to have the horizontal and the vertical as a thing. It appears anytime the ray is perpendicular to surface. Yeah, I think so. But it doesn't seem to be every surface. But it's so someone actually submitted a fix for this already, but I need a test for it. And also I just didn't accept their pull request yet because they're doing lots of things that I planned to do live on the show like we're doing right now. Oh. I have to actually give it a name test. Who would have thought? What? What? Did it create a new? I thought it was. Oh, all right, fine. What am I looking at? Start of 0, -1, end of 0, 1. Why are you telling me those two aren't equal? Because it's returning a tuple of elements. It's the distance followed by other things. I see what's happening, yeah. Yeah. Intersecting segments. The result is the distance, the point, and then the segment. That it. The distance, the point, and then the segment. Oh, this is clearly going to work. Hmm. All right, that's clearly like a distant point here. All right, I'm going to stop here. It's time for me to stop. All right, thanks everyone for hanging out. This was fun. What have we been on here? 2.5 hours almost exactly. I need to get ready for other work things that I have going on this week, most notably tomorrow. So thanks a lot, everyone. Again, we're going to figure this out at some point in the future. But I will catch you later. I don't think I'll be back on again today. Probably not.